Imagine waking up one morning and realizing you're completely alone. Not just in your city or your country, but across an entire universe. No neighbors for 330 million light years in any direction. No distant lights in the sky. Just endless, crushing darkness. This isn't science fiction. This is the reality of the Boötes Void. And if Earth existed there, we would have thought we were the only galaxy in existence until the 1960s. Today, we're diving into one of the cosmos's most unsettling mysteries. A region so impossibly empty that it challenges everything we thought we knew about how the universe works. It was 1981 when astronomer Robert Kirshner and his team were conducting what seemed like routine sky surveys, mapping galaxies across the heavens. They were looking at a patch of space in the constellation Boötes, the herdsman. What they found wasn't just unusual, it was impossible. Where there should have been thousands upon thousands of galaxies clustered together like cities across a continent, there was nothing. A spherical region of space, 330 million light-years across, containing almost no galaxies at all. To put that in perspective, if you could travel at the speed of light, the fastest thing in the universe, it would take you 330 million years just to cross from one side to the other. The team ran their calculations again and again. They checked their instruments. They wondered if there was some cosmic dust blocking their view, like fog obscuring distant mountains. But no, the void was real. They had discovered what would come to be known as the Boötes Void, or more ominously, the Great Nothing. In a region that should contain around 2,000 galaxies, based on the average density of the universe, they found only 60. That's a 97% deficit. It's as if you walked into a major city expecting millions of people and found only a few thousand scattered across empty streets. But here's where it gets truly mind-bending. This isn't the only void out there. The Boötes Void is just the first one we discovered. There are others, hundreds of them, scattered throughout the cosmos like bubbles in foam. Some are even larger. Let's do a thought experiment. Imagine our Milky Way galaxy somehow existed inside the Boötes Void instead of where it is now. You're standing on Earth, you look up at the night sky, and you see your own galaxy's stars. That's it. No Andromeda galaxy, no distant spiral arms of light, no fuzzy patches revealing galaxy clusters billions of light years away. For all of human history, from the ancient Babylonians to Galileo, from Newton to Einstein, we would have believed we were alone. One galaxy in an endless sea of darkness. It wasn't until 1923 that Edwin Hubble proved other galaxies existed beyond our own. But in the void, we wouldn't have discovered our cosmic neighbors until the 1960s, when our telescopes finally became powerful enough to detect the faint, distant galaxies at the void's edge. Think about how that would have changed everything. Our philosophy, our religions, our understanding of our place in existence. All built on the assumption of cosmic solitude. The psychological weight of such isolation is almost unimaginable. But this raises an even more disturbing question. What created these voids? How does a region of space this enormous become so catastrophically empty? Nature abhors a vacuum, or so we're told. Yet here we have vacuums on a scale that makes our entire galaxy look like a grain of sand. To understand the voids, we need to rewind. All the way back. 13 billion years, to be precise. To the moment of the Big Bang. In the first fraction of a second after the universe burst into existence, it wasn't the smooth, uniform sea of energy you might imagine. There were ripples, tiny quantum fluctuations, irregularities smaller than an atom, that would eventually shape the entire structure of everything we see today. As the universe expanded and cooled, gravity went to work. matter began clumping together, drawn to the slightly denser regions created by those primordial ripples. Where matter gathered, more matter followed. Like water droplets merging, galaxies formed. Where matter was sparse, it became even sparser as gravity pulled everything toward the denser regions. Over billions of years, this process created what cosmologists call the cosmic web, and it's one of the most beautiful structures in nature. If you could see the universe from outside, you'd see vast filaments of galaxies, stretching across space like strands of spider silk, connected at massive galaxy clusters that serve as cosmic intersections. These filaments can stretch for hundreds of millions of light years. And between these filaments, the voids, enormous bubbles of near-empty space like the gaps in sea foam or the air pockets in Swiss cheese. The Boötes Void is one of these bubbles, a place where, billions of years ago, there simply wasn't enough matter to seed galaxy formation, and gravity has been pulling what little was there toward the edges ever since. But here's the truly fascinating part. The voids aren't completely empty. Those 60 galaxies inside Boötes didn't just appear from nowhere. Some formed early, before the void fully emptied. Others might be passing through. And scattered throughout the void, invisible to our telescopes, is dark matter. The mysterious substance that makes up 85% of all matter in the universe, but doesn't emit any light. We can only detect it through its gravitational effects. The voids are also expanding. As the universe continues to grow, these empty regions are getting even larger, and the filaments connecting galaxy clusters are stretching thinner. In the far future, trillions of years from now, the voids will dominate. The universe will be a cold, dark place with islands of matter, separated by unimaginable distances of nothingness. For decades after the discovery of the Boötes Void, we could only map these structures in 2 dimensions, like drawing constellations on the dome of the sky. But in July 2023, something remarkable happened. The European Space Agency launched the Euclid Space Telescope, named after the ancient Greek father of geometry. Euclid's mission is audacious: to create the first detailed 3-dimensional map of the universe. Over 6 years, it will observe billions of galaxies, stretching back 10 billion years in time, mapping not just where galaxies are, but where the invisible dark matter lies and how the mysterious dark energy is accelerating the universe's expansion. The telescope works by measuring the shapes of distant galaxies and how their light bends as it travels through space, an effect called gravitational lensing. When light from a distant galaxy passes near a massive object like a galaxy cluster or a concentration of dark matter, space itself bends, distorting the image we see. By analyzing these distortions across billions of galaxies, Euclid can map the underlying structure of both visible and dark matter. And the voids, they're one of Euclid's primary targets. By mapping them in 3 dimensions, scientists hope to answer fundamental questions. Are the voids truly empty, or do they contain vast amounts of dark matter we simply can't detect? How do they form and evolve? And most intriguingly, do they hold clues about dark energy, the mysterious force causing the universe's expansion to accelerate? Some theories suggest that the voids themselves might be shaped by dark energy, that their emptiness might actually tell us more about this cosmic enigma than studying galaxies does. If true, the Boötes Void isn't just an empty curiosity, it's a laboratory for understanding the fundamental forces shaping our universe. Early data from Euclid has already begun revealing the cosmic web in unprecedented detail. The images show filaments and voids with a clarity that would have been unimaginable just a decade ago. We're watching the skeleton of the universe emerge from the darkness, and it's more intricate and more beautiful than we ever imagined. The Boötes Void sits there in the constellation of the herdsman, a monument to emptiness on a scale our minds struggle to comprehend. 330 million light-years of almost nothing. A cosmic desert where galaxies are as rare as oases. But perhaps that emptiness isn't the point. Perhaps what the void really teaches us is about connection. Every time we look at the night sky, we're seeing the result of 13.8 billion years of matter choosing to come together rather than drift apart. The galaxies we see, the stars they contain, the planets orbiting those stars, and the atoms making up our bodies. All of it defied the pull toward emptiness. We live in the filaments, in the places where matter congregated, where gravity drew gas clouds together to ignite into stars. We exist on the edge of the void, looking out into that great darkness, and we've chosen to explore it rather than fear it. The universe is mostly empty space, but where matter gathers, where forces interact, where gravity sculpts and stars ignite, that's where the story happens. That's where we happen. And in learning to map these voids, in sending our telescopes to pierce their darkness, we're writing the next chapter of that story. The Great Nothing isn't the end of curiosity. It's an invitation to wonder what else might be hiding in the dark, waiting to be discovered.